Hi, this is Sung. I'm the Principal and Director of Sky Academy, and today we're going to start a new topic. So welcome if you're watching for the first time, and the topic that we are starting is geometric applications of calculus. So in the last course that we did, we basically touched through the derivative, differentiation as a concept, and finding the derivative. And in this topic, we're gonna see how that all applies geometrically to the way graphs look, etc. Okay, so let's get started. The first derivative, or f dash of x of a function y equals to f of x, is basically the gradient function of the curve. By differentiating the function, it gives us another function from which we can work out the gradient of a curve. And when I talk about the gradient of a curve, what we're actually talking about is the gradient of a tangent on that curve. Okay, so f dash of x is the gradient function of the curve, and it gives us the gradient of the tangent to f of x, to the original function, at the point x. Okay, so let me explain what that all means. So if you have a curve that looks like this, y equals to f of x, then the tangent is a point that touches but does not cross the curve, right? And it touches at this specific point, and it kind of has, touches and kind of has the same gradient as the gradient at that point that it touches, the point of contact. Okay, so this tangent has the same gradient as that curve at the point of contact. In this particular case, our gradient is sloping this way, and as we all know from junior maths, a gradient that curves this way is positive. All right, so our gradient in this case is positive. So what we would expect is that our first derivative will also be greater than 0, positive. Okay. The second type of graph is where f of x looks like this, and it basically flattens out. And we know that a flat gradient is equal to 0. Okay, and so our curve also has a gradient of 0 at that tangent, at that point of contact, where that tangent is equal to 0. And we have a special name for those points. We call them stationary points, and we'll look more in detail in the next episode and in future episodes about what stationary points actually are. Okay, and then the last example, f of x, right, or the tangent at the point of contact to f of x is negative. So you have a negative gradient, which means that our derivative, our first derivative of the equation of the function, will also be negative at that point. Okay, so hopefully you will have understood that basically finding the first derivative of a curve tells us the gradient of the curve at that point. Okay, and we can tell that by the gradient of the tangent. All right, so thank you very much for watching. I'll see you on the next episode.